Hey guys, and welcome to this kind of video study guide for our upcoming quiz on factoring some sorts of polynomials. So as of now, there are really only three types of polynomials that we know how to factor. One of them is our set of perfect square trinomials. Another is the set of quadratic trinomials, meaning the highest exponent on variable is just 2, with leading coefficient 1. So note that in this example, the coefficient on m squared is just 1m squared. And the third type of polynomial we've learned how to factor is difference of squares. So h squared minus 25 in this case. So as of now, in each problem set, we've dealt with each of these types of polynomials individually, right? We always knew what was coming when we were going through a problem set. So it made it a lot easier to factor those polynomials. But how can we look at a random polynomial, and we don't know what type it is, and quickly determine what the best strategy is going to be? So what we're going to do now is we're going to come up with a little checklist to help us classify each polynomial, figure out what we're looking at, and then figure out what the best strategy is to factor it. Now, there are two steps that we are going to do first whenever we factor any polynomial of any variety ever. And perhaps you know what they are. Take a moment to think about it. I think the first thing I always do is I try to put my polynomial in standard form. Right, every time we've factored a polynomial to date, it's just a lot easier when it's in that standard form. That's going to make it a lot easier to classify. And then the next thing I always do before we start doing any more classification is look for those common factors and factor them out. Okay, so once we've done both of those, put the polynomial in standard form, looked for and factored out any common factors, now there are really only a few possibilities for what we could be looking at. And the first is to determine, well, how many terms are there? Is it a binomial that we're left with, 2 terms, or is it a trinomial that we're left with 3 terms? If it's a binomial with 2 terms, there's only one possibility for something that we can factor. We're looking for differences of squares. And remember, a difference of squares is any polynomial, a binomial, that is of this form. Something squared minus something else squared. Okay. And if it's not that, then we really, right now, don't have the skills to factor it. Okay, the only other possibility for how many terms it could have, for polynomials we know how to factor right now, is it could be a trinomial with 3 terms. And if it's a trinomial with 3 terms, there's only 2 possibilities. And the first thing I look for is, well, is it one of those really nice quadratic trinomials with leading coefficient 1? That's the first thing to look for. And if it's not one of those, if it's not one of those nice quadratics with leading coefficient equal to 1, the only other possibility right now for polynomials we know how to factor is maybe it's a perfect square trinomial. So first I would look to see if it's one of these nice trinomials. If not, look to see if it's a perfect square trinomial. And if not, then we're out of luck. We won't be able to factor it right now. So what we've got now is a strategy, a checklist that we can go through every time with any polynomial to quickly and hopefully accurately classify the polynomial and then determine what strategy is going to be best for factoring it. So from here, this is a normal study guide. I've got a whole bunch of different examples that kind of highlight every single type of polynomial we know how to factor with different kind of variations. So what I would do now is I'd stop the video and I'd go ahead and I'd try all of them, and then I'm going to walk you through each of them as well. And it's kind of like a video answer key, if you will. And hopefully you don't need it at all, but if you do, you can play it and we'll see how it goes. All right, so here we go. Looking at this first example, first question, is it in standard form? Yes. Awesome. Are there any common factors? No. Okay, we're ready to try to classify it. I see that it's a binomial with 2 terms. We're hoping that maybe it's a difference of squares. Well, I think a squared is definitely a perfect square. It's a squared. Is 9 a perfect square? Absolutely. That is the square of 3, meaning we can factor this as a plus 3 times the quantity a minus 3. And we're done. All right. Moving on to our next example, number 2. Okay. Is this in standard form? Yes. Are there any common factors? Yes. It appears that 2, or even better, negative 2, is something that we can factor out from this trinomial. So I'm going to factor this as negative 2 times the quantity of w squared minus w minus 30. So now what we're really looking at is this remaining trinomial. And we say, okay, can we classify this trinomial? Is this a quadratic trinomial with leading coefficient 1? Yes. Yes, it is indeed. We got a 1w squared minus w minus 30. So we immediately know, aha, that remaining trinomial will definitely factor as w plus some number and w plus some number. And all we need is that these two numbers together, they've got to multiply to negative 30. And when we add them together, they've got to add to negative 1. That's the coefficient on w. So I think that's going to factor as w minus 6 times the quantity of w plus 5. And don't forget, in our final factorization, we need to include all the factors, including the common factors from before. So that would be our final factorization there. All right, moving on. Might as well box this one too. All right, number 3. Okay, is this in standard form? Yes, phenomenal. Are there any common factors? Nope. Okay, it's a trinomial. Is it a nice quadratic trinomial? Yes. Is the leading coefficient 1? No. Okay, so scratch that off our list. So the only other hope is maybe this is a perfect square trinomial. That's all we've got going for us. And if it's not, right now we don't have the skills to factor it. Well, is this first term a perfect square? Oh, you know what it is. I think that's 7h quantity squared. Is this last term a perfect square? Absolutely, that's 2 quantity squared. So there's the possibility that this polynomial could be 7h plus 2 quantity squared, or maybe 7h minus 2 quantity squared. This negative 28h as our linear term leads me to believe that the only candidate is 7h minus 2 quantity squared. And now you need to do a little mental math, a little multiplication to check and see if this actually is the correct factorization. And you know what? It actually is. And so, boom. There we go. We're done. So hopefully you're kind of getting the hang of this, and hopefully if you've been kind of following along so far, you can try some more on your own. Making our way to number 4. All right, are we in standard form? Yes. Are there any common factors? No. Is this a nice trinomial quadratic with leading coefficient 1? Yes, it is. This is a very nice one, so we immediately know, oh, this is great. This is going to factor as m plus some number times m plus some other number. And we know these numbers, when they multiply together, you're going to have to get 49. And considering those middle 2 steps of multiplication, when these numbers add together, we're going to need to get 14. So when we multiply these, we get 14m. What 2 numbers multiply to 49, but also add to 14? Positive 7 and positive 7. So in fact, this also happens to be a perfect square trinomial. Note that this one, we can classify it as both a nice quadratic with leading coefficient 1 and a perfect square trinomial. Sometimes that happens. Use whatever strategy you want. All right, moving on. All right. Okay, number 5. All right, here we go. Are we in standard form? Yes. Are there any common factors? Yes. We can write that as 3 times the quantity of g squared plus 25. So we've got a binomial, so we're looking for a difference of squares. And you know what? G squared is a perfect square. 25 is a square as well, but because we're adding them, they're actually, right now, we do not have the skills to factor this polynomial. If you wanted to factor it, you'd actually have to use imaginary numbers. So we're done. That's all we can do with this guy. But it is still important that we factor out that common factor of 3. I think this is going to be a more user-friendly version of this polynomial. So please do look for that common factor anyway, even if you know you're not going to be able to go any further. Okay, number 6, making moves. All right, we are in standard form. I do not see any common factors. This is not a nice trinomial with leading coefficient 1. Hopefully it's a perfect square trinomial, so let's do some investigation. Ooh, our first term is a perfect square. That is 3n quantity squared. Our last term is a perfect square. It's 5 squared. So if this guy is a perfect square, then it would be 3n plus 5 quantity squared. That's a big if, though. Let's do some mental math. If we were to actually multiply together 3n plus 5 times itself, is this the polynomial we get? In fact, it's not. It is not the polynomial we'd get. If we were to square 3n plus 5, we would get 9n squared plus 30n plus 25. So alas, this is not the factorization. You can either write something like this, you can erase the whole thing, you can put a big X, you can say does not factor, but right now, we don't have the skills to factor this polynomial. Okay, making moves. All right, we're in standard form. Are there any common factors? Yes, there are some common factors, or a common factor. I think we can write this as 25 times the quantity of b squared minus 5. All right, so our remaining polynomial here, this is kind of what we're concentrating on now. I see that it's a binomial, so the only hope is if this is a difference of squares. And you know what? It is a difference of squares. While 5 is not a quote-unquote perfect square, I think we can write it as the square root of 5, quantity squared. Meaning that this binomial, it factors as b plus the square root of 5 times the quantity of b minus the square root of 5. And of course, we do not want to forget about that other factor, our common factor from before. And so here is your fully factored version of this polynomial. So, got to keep all those skills in mind that sometimes irrational numbers and square roots are going to pop up. All right, continuamos. We continue. All right, are we in standard form? Oh, we're actually not in standard form. So let's go ahead and put this in standard form. First things first, a squared plus 2a minus 24. Okay, now we're in standard form. Are there any common factors? Nope. Okay, so we're going to classify this as a trinomial. It is a nice trinomial with leading coefficient 1. That's amazing. That means we're definitely going to be able to factor this as a plus something times a plus something, or at least we hope we're going to be able to factor. If it does factor, this is how it would factor. So now we're looking for two numbers that multiply to negative 24 but add to positive 2. Oh yeah, a plus 6 times the quantity of a minus 4. And we're ready to rock. And you can always, to check your work, you can actually just go ahead and multiply these together and see if this is what you get. And if it's not, then we've made a mistake. Okay, looking at number 9. Yowza, we got some big numbers here. We are in standard form. That's nice. Are there any common factors? Oh, yes, there is a common factor of 5. That's nice. I don't like working with big numbers, so I like hopefully finding common factors that make life a little bit easier. All right, now we're looking at this remaining trinomial right here. Let's classify it. Oh, it is a nice quadratic trinomial leading coefficient 1. That means that if it factors, it would factor as such. G plus some number, or G plus some number, or maybe minus some number. Okay, let's see. We need two numbers that multiply to positive 18 and add to 11. I'm thinking G plus 9 times the quantity of G plus 2. Don't forget our common factor from before, and we've fully factored that original polynomial. Okay. Number 10. Woo! All right, we are in standard form. Is there a common factor? Yes, I think there's a common factor of G squared. Remember that the coefficients could have a common factor, but also don't forget that the variables can be part of it as well. So I think we can write this as G squared times the quantity of G squared plus 6G plus 9. And now we're looking at this remaining trinomial. It is, again, a nice trinomial, a quadratic trinomial leading coefficient 1. So we know that if it factors, it's going to factor as G plus some number times G plus some number. We need two numbers that multiply to positive 9 and add to positive 6. Thinking G plus 3 times G plus 3. Don't forget our G squared common factor from before. And if you want, you can write this as G squared times the quantity of G plus 3 squared. So it turns out that this polynomial right here that we were classifying earlier could be classified also as a perfect square. But since it's also a nice trinomial leading coefficient 1, that's how I like to work with it. So I'll leave that choice to you. All right, just a few more. Okay, ooh, we got some fractions here. So, all right, are we in standard form? Yes. Are there any common factors? No. All right, but it is a trinomial, so we're thinking, okay, is it a nice quadratic trinomial leading coefficient 1? I mean, I guess it is. I really never even thought of it this way. I guess it is. And so I guess what we're looking for is, we'll do this in two different ways. We know that we can factor this as h plus some number times h plus some number. And we need these two numbers to multiply to 25 fourths, but add to 5? And in fact, the numbers that do that are 5 halves and 5 halves. The other way I would look at this is to say, you know, once I see these nasty fractions in these trinomials, I'm kind of led to believe, you know what, it's probably hinting towards being a perfect square trinomial. And of course, the leading coefficient, the leading term is a perfect square. 25 fourths is also a perfect square. And so we ask ourselves, is it the case that this polynomial could be h plus 5/2 quantity squared? And if you do your multiplying to check, you find out that yes, indeed it is. So I guess you could regard this polynomial in either one of those ways. Okay, moving on to number 12. I see we have a polynomial in standard form. Are there any common factors? Yes, there is a common factor of 3. So let's write this as 3 times h squared plus 3h minus 8. Okay, now we're looking to classify this remaining trinomial. Again, it happens to be a nice trinomial, quadratic, leading coefficient 1. That means if it factors, then it would factor as h plus something times h plus something. We need these two numbers to multiply to negative 8, but add to positive 3. You know what? I'm drawing a blank. I don't think there are any factors of negative 8 that also add to positive 3, so you know what? That's it. We actually can't factor anymore. This is as good as it's going to get. So this would be our fully factored version for now. Later we might develop the skills to factor this, but not right now. All right, just two more. Here we go, number 13. Are we in standard form? Yes. Is there a common factor? Yes, I think v squared, or even better, negative v squared, would be a common factor worthy of factoring out, because that leaves us a nice positive v squared minus 13v plus 36. So now we're looking to classify this remaining polynomial. It's a trinomial. And again, it happens to be another one of those nice trinomials. Quadratic, leading coefficient 1. So if it factors, it'll factor as v plus some number times v plus some number. We need two numbers that multiply to positive 36 but add to negative 13. You know what? I'm thinking v minus 9 times the quantity v minus 4. And so don't forget our original common factor from before. Here is our fully factored version. Okay, last but not least, number 14. We are in standard form. Are there any common factors? Yes, a v, or even better, a negative v in this case. If we factor out a negative v, we're left with v to the 4th minus 16. All right, now we're classifying this polynomial, this binomial. So we're hoping it's a difference of squares. It is a difference of squares. I think we can factor that as v squared plus 4 times the quantity of v squared minus 4. You can multiply those together to confirm. And note, while we might think we're done, we want to keep on factoring as far as we can to make sure there's nothing left we can do. Now v squared plus 4, well, v squared is the perfect square, and 4 is the square. Since there's addition here, we cannot factor this any further. But v squared minus 4, because we have a square and another square, and there's subtraction, that factors as v plus 2 times v minus 2. So definitely something to keep in mind. Of course, we're going to continue bringing down all of our other factors. But sometimes it can get really confusing as about what does factor further and what does not. And in general, we want to factor as far as we can until we cannot factor anymore. And so I hope you're feeling ready for this quiz, and I hope that this was really helpful.